It's you to analyze the question. You analyze the question, then see whether you're going to apply this concept. They are not going to tell you directly that this is conditional probability. Okay? But some questions, they can be specific that you use Bayes theorem. Okay? But what is conditional probability? This conditional probability is basically the probability. Let's just summarize a few things as we dive into the calculation. This is the probability. This is the probability of an event happening. Given that another event has already happened, has already occurred. That is conditional probability, and it is denoted as the probability of, let's say, first event, given that B has already occurred. Okay, that is where A is the event of the interest, what you're interested in, and B is the event that has already occurred. Something that you need to know here. A is what you're interested in. Then B is the event that has already occurred. That is conditional. That is conditional probability. That is conditional probability, just in simple terms. And we are going to see how do you approach questions with conditional probability. For questions, when you check on that YouTube channel, I discussed already the August 2018 number. You will check there. I am not going to repeat. It is August 2018, question 3. I discussed a number about Bayes theorem. Now I am going to discuss, already discussed. This is already discussed. So visit the YouTube channel. Okay, YouTube channel. If you want to know that number, visit and see how we handled that. Okay. Then now we are going to look at December 2022. Question, it was question, I think, question 2. Question 2, part C. Then we are also going to discuss September 2022, question 2, part C. Very, very easy when you understand the steps that we follow to answer this question. The question that involves conditional, probability. Okay, so we are going to start with December 2022. December 2022. This is question 2. We have already discussed all these ones. Just follow the recordings, follow the session. These ones we have already discussed them. This was about what? This was about binomial distribution. Then part C was about normal distribution. We have already discussed that. I believe also this one we discussed. We are good to go. Now we are looking at part what? Part C. We are looking at part C. You see that they have not told you use conditional probability. They just said determine the probability. We are told to determine the probability that the person involved in the accident was a boda rider. Determine the probability that the person involved in the accident was a border rider. What is the probability of interest? This is your probability of interest. This is your probability of interest. Now, it will always depend on something that has already occurred. That has already occurred. Conditional probability. Something has already occurred. Now, when we are answering a question about conditional probability, when we are using Bayes theorem, we have the steps that we normally follow. We have the steps that we normally follow. And the moment you understand these steps, it will be easy for you to tackle any number. It will be easy for you to tackle any number. So as I answer that question, I am also going to be giving you the steps. Step number 1, always define the events. Always define the events. Always define the events. So from this question, what are the events that we have? What are the events that we have? Now, when you look at this question, we are told that an insurance company insured 2,000 border riders. Okay? An insurance company insured 2,000 border riders, 4,000 car drivers, and 6,000 truck drivers. Those are your events. Those are your events. Those are your events. So define, as you define, you are going to say that, let's say, you are going to say, let, it could be my, how can I could say let A be the event choosing a border rider. That is number 1. That is your event. How? Because we are having 3. We are having border rider, car driver, and a truck driver. So we are also going to say let B be the event of choosing a car driver. Then C, let's see be the event of choosing a truck driver. A car driver. Okay, so that is our events. We have defined our events. So the events will always base on what you are given. What you are given in the question. Okay? What you are given in the question. Okay? That is number 1. Then we are told that the probabilities of an accident occurring. Are you seeing that? We are told that the probabilities of an accident occurring involving involving car and truck driver are 0.01, 0.03, and 0.15 respectively. So these are probabilities. Now, after defining your events, number two, you have to look at you determine the probabilities. Determine the probabilities of events. That is step number 2. Let's determine the probabilities of these events. What is the probability of you choosing a border rider who is insured? What is the probability of choosing a car driver who is insured? What is the probability of you choosing a truck driver who is insured? So that's what we are going to do. That's what we are going to do. That's what we are going to do. And when you look at the question, we are given the total number of border riders that were insured. Like here, there are 2,000. We are given the total number of car drivers that were insured. We are also given the total number of trucker drivers that were insured. So it means that I can be in a position to get. We have the total. What is the total number of insured? The total number of insured persons, insured drivers, insured persons. Okay, so we can get the 2,000. Guys, can you hear me? Yeah, don't get tired, because I don't want to be speaking to myself. 2,000 plus what? 4,000 plus what? The 6,000. 2,000, these are border riders. Then 4,000, these are car drivers. Then 6,000, these are trucker drivers. So the total you get what? When you add very fast and tell me the total. Add very fast and tell me the total. That is what? That is
12,000.
12,000. These are insured persons. So if you have the total, you can easily get the probability. So the question is, what is the probability? What is the probability of choosing A? What is the probability of choosing A? What is the probability of you choosing a border rider who is insured? So the probability of A will be what? It will be the 2,000 divided by what? The 12, the total. What do you get? Decimal, you can use the decimal points. You can use the 2 decimal points.
0.17.
What about probability of B? You will hear someone saying that
0.33.
hard. Hmm? Yeah, you get
0.33.
Then here,
0.5.
0.5. Guys, if you add the total probability, should give you 1. First confirm. The moment you find that the total probability is not 1, know that you're wrong. Okay? Is it 1?
It's 1. Yes.
Okay. So we have the total number of the insured persons. We have determined the probabilities of events. Sometimes you may find that you're given these probabilities direct. You may find that these probabilities are direct, but like now in this question, they are not direct. But at this point, are we together? At this point, are we together? Before I go to number 3, step number 3. So step number 3. Step number 3, we are going to do what? We are going to determine the conditional probabilities. We are going to determine the conditional the conditional probabilities. Okay, that is step number 3. Step number 3. Determine the conditional probabilities. Now, as you determine this, as you determine step now, as you do your step number 3. Now, for you to get the conditional probabilities, for you to get the conditional probabilities, you must have an event that has already occurred. You must have an event that has already occurred. So we are going to say that let's say E be, let E be the event. Let E be the event that an insured person gets an accident. Let E or any letter be an event that an insured person gets an accident. Why are you saying that, colleagues? Why are you saying that? Why are you saying that? Because when you are looking at required part, we are told to determine the probability that the person involved in an accident was a border rider. So we want to know the event that an insured person gets an accident. Okay? Because here we are told that given that there was an accident on a Monday morning, okay? So we are going to say that let E be an event. Let E be the event an insured person gets an accident on Monday morning. So the probability that an insured person gets an accident, given that he was a border rider. What was a border rider? We define those border rider as A. So here you get what? Are you given that probability? Because here you are given these probabilities. We are told that the probabilities of an accident occurring, are you seeing that? Involving the probability of an accident occurring involving a border rider was 0.01. So that is what we are putting. That's what we are putting, 0.01. Then also the probability that an insured person gets an accident, given that in an accident is a car driver. What is that probability? Aren't you saying that it is 0.03? Okay, so the last step. The first step, we are going to get the total. Now, what is the total? First step, determine the total probability. The total probability of determine the total probability using the law of let me say using the Bayes theorem. Now, when you are getting the total probability using the Bayes theorem, what is the total probability here that you're trying to get? What is the total probability that you're trying to get? You are trying to get the probability of E. The probability, you see that we don't have E. We don't have E. We don't have the probability that the insured person gets an accident on Monday morning. We don't have that. We don't have that. So what is that probability? What is that probability? Now, to get that probability, simply always record this formula. We are going to say this probability of, we are going to combine, because the probability that an insured person gets an accident, we have different persons. We have different persons. So as you get that probability, you're going to just simply say the probability of choosing A, we are going to get A times this is probability times when you look at what you have, you're going to multiply by these. You're going to multiply by what? By these conditional probabilities. So we multiply by this. We multiply by this. The one corresponding to A. I don't want to, because the moment you have step one and 2, it becomes very easy. Then here you add the probability of, just understand this formula. So substitute in the formula. What was the probability of A? It was 0. What? From your book, probability of A, it was 0.17. Then times what is probability of E given A, it is 0.01. Then plus what is probability of B? That is 0.3. Then times what is probability of E given B? 0.03. Then you add 0. What is the probability of C? That is 0.5 times E given C. So finally, you get what? You put everything on your calculator and tell me the total. Just give me two decimal points or 3 decimal points.
Is 0.09.
All of you, that's what you have? So the last step, this is the last one, really. This is the last, this is the last one. The last one now, you go back to the required part. The last step, look at the required part. When you look at the required part, when you look at the required part, we are told to determine the probability that the person involved in the accident was a border rider. What is the probability of interest here? What is the probability of interest here? The probability of your interest. Remember when we were defining the conditional probability, we say that it is the probability of an event happening given that another event has already occurred. So A is an event of interest. Then B is an event that has already occurred. So what does this one mean? I am looking for the probability of an interest. What is an event of an interest? The event of an interest is the one of border rider. Is the one of border rider. That is the one of interest. The one of this one. This one is the one of we are interested in this. determine the probability that the person involved in an accident. An accident must first occur. An accident must first occur. Then an event has occurred. What is that event? An accident has occurred. Then we ask ourselves, in that accident, what is the probability of finding that we had the boda rider? So the interest, your interest, the event of interest is the boda rider because it comes after an accident has occurred. Okay, so we are going to say that the probability of what was our boda rider? We had defined the boda rider as what? As A. So A given that what? Who can tell me A given what? A given E. Because we had determined E as an insured person that an insured person gets an accident. So we are going to say A given E. E is that the person, okay, E is the event that actually an accident occurred. So what do you get? This is what we are looking for, guys. This is what we are looking for. Are you seeing that this one is different from this one? Is different from this one? This one. They are different. They are different because of the question. Okay. Now, the simple approach you are going to always use to determine this is very, very easy. The one you have here, the denominator will go down. Will go down. Then for numerator, this is what we do. So what do we get? We have everything, guys. Just substitute. What is probability of A? Probability of A is 0. It was 0. Actually, you can copy and paste. You see, you can copy and paste because you have everything here. You just copy and paste. So you divide everything by this. What do you get?
I have 0.0188.
0.188, which is like 0.019. Okay, so that is the final. That is the final answer, guys. That is the final answer. You are done with the question. You're done with the question. You see just these steps. You see only these steps, and you score all your marks. Any question? We are done with December 2022. We are done with December 2022. So let's look at September. Let's also look at September, and we see September. We are told that you find the probability that it is due to the appointment of Kathy. But what are we told? We are told that 3 people, Brian, Peter, and Kathy, applied for a job. You guys can hear me? Alex, can you hear me?
Yes, I can hear you.
Okay. So here we are told that 3 people, Brian, Peter, and Kathy, applied for a job of a manager in a private company. Their chances of being selected are in the ratio of 1 to 4. So this is here you're given the chances of them being selected. So first of all, when you look at your step one, basing on what we had discussed from the other question, this is September 2020, what? This is September. This is September 2022. Question, is it question what? Question 2? Question 2 part C. So we are going to say let A, B and C be the events of selecting, selecting who? Selecting Brian. Who is the first person? Brian? Brian is the first person. Let A be the chance of
Brian is the first person.
let A be the event of choosing or selecting Brian. Then next B is at selecting who is the next person? That is Peter and Kathy respectively. That is step number one. Then step number two, what is their probability? What is the probability of, what is the chance of choosing Brian? What is the chance of choosing Peter? What is the chance of, this is Peter, what is the chance of choosing, Kathy? Okay, so what is the chance of choosing A? What is the chance of choosing B? What is the chance of choosing C? We are on step 2. Of course, I say that like now here, what we are given, we are not given the total. We are given 3 people, but the chance of selecting are in the ratio 1 to 4. So it means that the probability of selecting, let's say Brian, is 1 out of what?
7. Get the total.
This is 0.1 out of
7.
1 out of 7. 1 out of 7. This is 1 out of 7. Then here it is
2 out of 7.
2 out of 7. Then here
4 out of 7.
4 out of 7, which is
0.57.
0.57. That is the last one. Then here
Yes. The first one is 0.14.
0.14. Then here
0.29.
Just a minute. Okay. I'm back. Can you hear me?
Yes.
Okay, sorry for the delay, but sometimes those things happen. Okay, where are we? We are on this. We have now the probabilities. Then what is the next? Next, we are told that the probability that Brian, Peter, and Cassie, if selected, will introduce changes to improve profits of the company are these ones respectively. Okay, that's what we are told. But if if the change in the profit does not take place, if the change in, are you seeing this word? If the change in profit does not take place. Sometimes when you are in an exam, you will not read this word, but it is very, very key. The probability that you're given, these ones, you are told that the probability that Brian, Peter, and Cassie, if selected, will introduce changes to improve profits of the company are these ones. But your focus is on the probability that the change in profit does not take place due to the appointment of Cathy. So here you're looking at the opposite side. You are given the probabilities that are rated to Brian, Peter, and Cathy. If selected, will introduce changes to improve profits. So it means that when you are dealing with this question, you need to pay attention. You need to pay attention. Here we are going to say that let E be the event that a change in profit took place. Okay. Let E be the event that a change took place. Now, what we are given is that we are given the probability that the change took place, given that it was as a result of appointing A. That one we have. Also, we have the probability of E, given that the change took place, given that it was as a result of B, appointing B. Then also probability of that the change took place, given that it was introduced by or it was as a result of C. You have these probabilities. You have these probabilities. And in the question, what are these probabilities? What are these probabilities? This is 0. Because here we are told the probability that Brian, Peter, and Cassie, if selected, will introduce changes to improve profits of the company. So we have 0.2, 0.5, 0.2. This is 0.2. This is 0.5. Then this is 0. This is 0. What?
0.3.
This is 0.3. Okay. So, but you see, we are not interested in basically what you need, guys, here. You need to really pay attention. You need to really pay attention, because here what you need is that if the change in profit does not take place, now it means that you are working backwards. Like if the change in profit does not take place, okay. Here what you have defined is the E to be the event that the change took place. Now, what is that? What is now the opposite of E can be E. That is like E. And we are interested in this. So if you are looking at this, it means that you need also to convert these ones. And how do you convert them? It means that you will need the probability of E bar, E sub given A, like that, E hyphen, okay, to indicate that, okay, let me put them here. Because here it means that we are not dealing with E, we are dealing with just the E bar, depending on how you want to call it. So this one is what? Who can tell me this? If you have 0.2 as the probability that the change took place as a result of A, it means that the remaining balance 1 minus 0.2 is the probability that the change did not take place, which is 0.8. Then here it is this one. given B. And here you're getting what? 0.5. That is the balance. Then here it is also this one. This is 1 minus 0.3, which is 0.7. Okay? Okay? All right. So finally, what is the probability of E bar? What is the probability that there was what is the probability that no change took place? What is the overall probability that no change took place? So you simply get probability of A times probability of this, then plus probability of B, then times probability of E, like this over B, then plus probability of C, then times probability of something like this. Okay, so substitute in the formula and get the answer. So this will be 0.2 times 0.2 times 0.8, because then plus 0.2 is coming from where? Sorry. It is not 0. What is the probability of A? Probability of A is 0.14. 0.14. Then times the probability of it is 0.8. Then plus, what is the probability of B? Probability of B is 2.29 times what? Times 0.5. Then plus C is 0.3. 0.7.
It's 0.5.
The overall answer.
No. It's 0.57 times 0.7.
Yeah. Probability of C is 0.57. Yeah. Probability of C is 0.557. Okay. What do you get? What do you get? Pardon, 0.56. 5, eh?
656.
656. 656. So that is the overall probability. But you need what? You need the probability that what? Remember, you want what is the event of interest? The event of interest is the appointment of Cathay. The change did not take place. If the change in profit does not take place, find the probability that it is due to the appointment of the Cathay. What is the previous event? what is the event that occurred? The event that occurred is that we are not seeing the change in profit. That is the event that occurred. Now, what is the event of your interest? The event of your interest is the appointment of Cathay. Okay? That the appointment of Cathay did not result to change in what? To change in profit. There was no change in profit because of the appointment of Cathay. So we are going to say C, given that the change, there was no change in profit. So what do you get? How do you get this? Who can tell me? Now you are looking at C. Are you seeing that? You're looking at C. So it means that I just copy this. I just copy this. Then everything I divide by E. Everything I divide by E. What do you get? You will get this one. Then divide by 0.656. What do you get?
0.608.
0.608. That's what we have. That's what we have. I believe that's very, very, very easy. Aren't you saying that this number is very, very easy? Just you need to follow. You need to follow what you are given. You need to follow and you need to read the question carefully. You need to read the question carefully. It's because sometimes you'll be dealing with E, something like this, or you'll be dealing with this one. Okay? So that's all.